So thanks everybody for coming today. Let me begin by acknowledging the First Nations peoples whose land we meet today, and also pay my respects on behalf of the College of Asia Pacific and the ANU to elders past, present and emerging. There's a concept that we like to use in relation particularly to environmental issues, which is called time inconsistency. And what that refers to is the fact that economic activities that we might carry out provide benefits to generations today, but the costs associated with those activities are borne by the young and indeed by future generations. Probably the best example of the time inconsistency problem is the problem of climate change, right? But we're gathered here today to launch Mercury Australia, and I would say it's another example in which activities, are leading to an environmental burden, which is going to be borne by the young and by future generations. So I'm really delighted to be able to say a couple of words as Associate Dean Research from the College of Asia and Pacific to launch Mercury Australia. And I'm delighted by it in relation to the time inconsistency problem because the intellectual architects of this problem are young researchers from the ANU and beyond. Although I should also add extremely accomplished, spearheaded by Larissa Schneider here at the front, and who's going to say a few words. I'm also really happy to be able to say a couple of words up front because the Mercury Australia project is a project that we've supported a number of different times from within the College of Asia Pacific. One of the fun things about my job as Associate Dean Research is that I get to chair a meeting in which we distribute funds under a program called the Asia Pacific Innovation Program. And the fund is designed to provide seed money to early career researchers and to established researchers who are developing projects which are significant pieces of research, but also which contribute to the national conversation around important policy issues. Larissa and the work that you're going to hear about today has been supported a number of different times by this program, culminating in a strategic research collaboration grant, which partly helps today happen. And I know that the team as a whole is also looking to develop this project in the future with partners external to the ANU in order to deliver further benefits into the future. And lastly, let me make a final point, which I think relates to the college as well in this particular project. One of the things that we really liked about this project is its interdisciplinary nature. I teach a class on energy politics, and when I sort of say energy politics is framed as a wicked problem, all the government officials in the room tend to groan because I guess they've been told this by senior people in the departments, and it's kind of become, this phrase, the wicked problems. But it's certainly the case that environmental issues and many other issues that we face in public policy today, are highly complex, and they don't respect disciplinary boundaries within academies or indeed within government departments as well. And one of the things that's really terrific, I think, about the team that has come together here, aside from the existence of young researchers as well as established scholars across the university and beyond, is that it is also highly interdisciplinary in nature, okay? So we have environmental chemists working together with legal scholars, with scholars of regulation, as well as hydrologists and others in beginning to think about the problem of mercury and how one might manage it. And I hope and think that it's really going to deliver in the future or demonstrate what the promise of interdisciplinarity really can be. I'm going to hand things over to Larissa to talk more about it because she knows far more about it than I do. Let me just tell you a little bit about the run. Today we have a number of different people who are going to make short remarks, and then we'll break, which will enable everyone to have a conversation in the room with one another with some light lunch, I believe, is here. Firstly, Larissa Schneider, who's the DECRA Fellow in the School of Culture, History and Language here at the College of Asia Pacific, will say some remarks. Then we'll have Associate Professor Darren Sinclair, who's a DECRA Fellow at the Institute for Governance and Policy Analysis at the University of Canberra, say some things, further things about the project. Also, Professor Peter Nelson here, who's the Pro-Vice Chancellor Research Performance at Macquarie University, who's involved And then finally, we're delighted to have James Tregurtha, who's the first Assistant Secretary from the Environmental Standards Division at the Department of Environment and Energy, close out remarks for today. So with that, thank you again for coming, and I'd like to pass the floor to Larissa.
Okay, so slight adjustment to the lineup of speakers today. Larissa and I are a tag team. So I'll just introduce ourselves. That's Larissa over there. I'm Darren Sinclair. We're the co-conveners of Mercury Australia, so we're going to do a sort of joint presentation. And I'd also like to mention that Professor Simon Haberle is going to give us some short remarks after us about the importance of multidisciplinary collaborative research. So thank you, Simon, as well. All right. Okay, so first of all, thank you everyone for coming along to the launch of Mercury Australia, particularly those guests and members of the network who have travelled interstate. We really appreciate your presence. So it's wonderful to have you here. First up, just a couple of acknowledgements. As Llewellyn mentioned, this wouldn't have been possible without the support, both strategic and funding support from the College of Asia Pacific, particularly through the APIP funding program, which is really designed to be a sort of seed funding to allow young researchers or any researchers get some ideas off the ground and hopefully grow into bigger and better things. Thank you for the other academics participating in the network, and particularly to our friends at the Commonwealth Department of Environment and Energy. We're developing a very constructive dialogue with them, and we're delighted to have James here from the department who's going to say some remarks at the end. So thank you for all that. And as Llewellyn mentioned, after we present, we'd like everyone to come down the corridor to the left to the tea room, and we'll have a chat over some lunch, which would be great. Okay, so Larissa, hand it over to you. She's going to tell us a little bit about why do we care about Mercury?
Yes, thank you very much for everyone for coming here today. I'll be starting talking about the basics of the Mercury. So, we're going to be talking about the group and what's the group, why we have the group. So I better talk a little bit about the background at the beginning. All right, so mercury naturally occurs in the environment. Okay, so it's typically found as cinnabar, which is a mineral with a red color, and it can be found like around the world. The raw form of mercury is attained through mining of cinnabar. Okay, that's the typical form of mercury that we know, especially if you're old as I am, and if you broke a thermometer when you were a child, you probably have seen mercury already. So mercury is the only metal that's liquid in room temperature, and that gives this characteristic gives like a good ability to study past climate change. And the color of mercury is like silver, so that's why it's also called quicksilver. So mercury exposure, even to small amounts, is very toxic. So it can cause problems with your neurological system, your digestive system, your immunological system, and you can also get problems in your lungs, in your kidneys, skin, and eyes. On top of that, mercury can cause congenital malformation. I mean, babies can be born with malformation. But how do we get exposed to mercury? Not only us, but wildlife as well. So once mercury gets deposited in the environment, it will go over bacterial activity, and then the mercury will be transformed to the organic form of mercury, which is called methylmercury. So this form of mercury readily crosses the cell membrane barriers in your body, and hence that's the form of mercury that we bioaccumulate. So the most important mercury bioaccumulation pathway is through diet. Okay, so basically, at the bottom of the food chain, plants, planktons, and other organisms uptake the mercury from the environment. And then any organism in this food chain that consumes the prey, which is contaminated with mercury, will have higher mercury concentrations than the prey itself. We call that biomagnification. So the effects are compounded the higher up you go in the food chain. Because we human beings are at the top of these food chains, as you can imagine, we are at the greatest risks of mercury bioaccumulation effects. Right, so why we should worry about mercury in an international level, not just only it's emitted? So as I said, mercury naturally occurs in the environment. However, in the last 200 years, we have been mobilizing mercury from Earth's crust to the atmosphere through industrialization, okay? To the point that nowadays, in parts of the world, we have atmospheric concentration of mercury, which is 4 to 6 times higher than it used to be before industrialization. So this mercury that's emitted to the atmosphere can take up to 1 year to deposit back to the environment. So as you imagine, a mercury that is in the atmosphere for 1 year can go anywhere where the wind takes it. So it doesn't matter if we protect mercury, if we control mercury in Australia, if Papua New Guinea hasn't been controlling mercury. So it should be an international effort. So we have 2 types of contamination in Australia, the historical and the contemporary one. The historical is basically a product of the European colonization. So the European colonization was heavily based on mining activities. And so these mining activities have released mercury to the environment. And as you can imagine, back then, there was no Environmental Protection Act in place. So the release of mercury to the environment was really not very well controlled. So one example of this problem as not being a past problem, but a present problem, is our recent study on hume pines. So we have identified that during a mining period, the accumulation of mercury in hume pine has more than doubled. So with the recent bushfires in Tasmania last December and January, that mercury has been released to the atmosphere because of the heat. So it's not a past problem only. Our contemporary sources of mercury in Australia is air emissions from coal-fired power stations, metal smelters, mining, mercury-containing pesticides, especially in Queensland, and mercury-containing products sent to landfill or incinerated. So now I'm going to hand to Darren. So I'm the scientist in the group. So I talk about science. Darren will be talking about the Minamata Convention. He's an expert in regulations, and he will be able to talk more about it.
Thanks, Larissa. So there's been increasing international recognition about the global nature of mercury, and this has led to a global treaty under the United Nations called the Minamata Convention on Mercury, which is designed to protect human health and the environment from the adverse effects of mercury, and is seeking to generate an international response to this issue. So that came into effect once it was established. There was enough evidence that the impacts warranted international action. The convention itself came into force in August of 2017. The convention had a clause in it that required 50 countries to sign and ratify it. Then it becomes an effective international instrument. That number now stands at 128 as of yesterday, I think it was. 128 countries have signed and ratified that international convention. So Australia has signed the convention, but we haven't yet ratified it. So I guess the expectation is that is going to occur sometime in the future. We don't know exactly when, but if and when Australia does sign that, then there will be certain obligations we're required to meet under that convention. So what are those obligations? What might be required to do? So if you look at the various provisions in the convention, I'll list some of those key ones. There's a requirement to reduce anthropogenic emissions and releases of mercury compounds to the environment, to phase out and phase down the use of mercury in various products and processes, to put in place controls on air emissions and releases to land and water, to have in place effective monitoring and implementation plans, and to establish an implementation and compliance committee. So Having said that, there is a 10-year phase-in period in which a ratified nation has to meet their various obligations. So it's likely that Australia is not super well placed at present to meet all those obligations. So there's a bit of work to do, and I'm sure the department would agree with that. So that's one of the reasons, of course, we're interested in forming the Mercury Australia Research Network. So just to give you a bit of a flavour of some of the regulatory and governance issues relating to mercury in Australia. So if we look at the state jurisdictions, we note that mercury has essentially been ignored in terms of state-based regulations, environmental regulations. For example, if you look at Victoria, there's actually no controls on mercury emissions from power stations at present. And in New South Wales, they're so high that it's almost meaningless. Power stations are required under the NPI, the National Pollutant Inventory, to report their mercury emissions. But this is a form of self-reporting. There's no independent reporting. They don't do continuous monitoring. And essentially, their reports on the amount of emissions are based on a formula, which is a desktop calculation based on the amount of mercury present in the various coals that they use, rather than actually measuring the emissions themselves. And if we look at the Australian best practice technology, or the lack thereof, if we compare ourselves to, say, North America and Europe, we note that the various control technologies on power station emission stacks, we haven't put in place the various technologies, particularly wet scrubbers and the like, which are effective at removing mercury from the emissions. So we're certainly well behind in that area. So what are some of the key knowledge gaps that the Mercury Australia Network might be interested in looking at? So we lag other jurisdictions in terms of our knowledge about the sources and impacts of mercury, but also in terms of our regulation and governance. We have limited empirical information on current sources and distributions of mercury emissions, particularly from coal-fired power stations. And there's work to be done in how best we should move forward in terms of regulation and governance of mercury looking into the future. So that brings us to our group, Mercury Australia. So what is the purpose of Mercury Australia? Why have we got together? So first of all, we want to bring together those people who are working in isolated spaces around the country, in various universities and so on, to bring together, have a conversation, to look at ways of collaborating and saying, what are the key issues and how can we work together, particularly through collaborative research. I'm particularly interested in and supportive of the concept of bringing together scientists and social scientists. So we often talk about multidisciplinary research, and often it doesn't happen quite the way people talk about it. But I can actually say, hand on heart, this has been a really genuine collaboration between scientists and social scientists, and that's reflected in the membership of the group, and also the types of issues we're interested in addressing. So we don't want to be navel-gazing, we want to look out and engage with others. So part of our raison d'etre, if you like, is to engage with state agencies, with industry groups, within NGOs, and also to work in a very supportive and collaborative fashion with the Commonwealth Department of Environment and Energy. And the nub of that, I guess, is to help Australia in its, assuming when we have, if and when we ratify the convention, to meet any anticipated commitments under that convention, but also to inform the community more generally about some of the issues surrounding mercury from a scientific independence point of view. Larissa, you are going to speak shortly, so I'll just talk a little bit about the network itself. So, as mentioned earlier, so we're a multidisciplinary, a multi-university group hosted by the ANU, and we have an MOU between the various participants. We've created a website, which is open to the public, obviously, which will act as a kind of a clearinghouse and a blog and a way of communicating and engaging with outside and within the group. On the mug. Has everyone got a mug? Yeah, that's the key thing. Get your mug. So we're kind of working on a future agenda, which, of course, the group itself will be able to modify that and evolve as time goes by. But we're working towards an end-of-year workshop where the group will come together and engage with various regulators in the Commonwealth, and hopefully that will feed into the international work at the Conference of the Parties of the next convention. We also want to put out an invitation more generally for others to join and engage with us, and morning tea, if other people are interested in having a conversation around that, we'd only be too happy to do that. Larissa, I think you're next, so I'll hand it over to you.
All right, did everyone get a mug? Just making sure. So we have more mugs there if you didn't get one. So I'm going to be presenting our group that's involved, all the members involved on the network, okay? So, well, I am a DECRA fellow here at ANU. So my research area is environmental chemistry, and Professor Darren Sinclair just spoke as well. We know him from University of Canberra, works with regulations and governance. Dr. Jenny Fisher from the University of Wollongong, she works with atmospheric pollution, so she's a modeler. Professor Simon Haberle is here from the ANU. He will be talking soon, so you're going to hear a little bit from him as well. And I actually want to special Simon, especially because I started ANU as a postdoc, and Simon was very open-minded to let me bring new ideas as a postdoc. So I basically started working with geochemistry. So before I was working with Simon, I was a PhD student with Bill and Frank. And so I had some experience working with geochemistry, doing geochemistry analysis in sediments. So then I started working with Simon, and then I brought the idea, oh, we should work with Mercury, you know? And Simon was very open-minded to say, yes, let's do it. So that's how everything started. So we applied for grants to get the equipment to analyze Mercury here. And I was giving lots of calls to Frank to get some of his devices for the lab. And that's how we started. So it's really important, I think, to have academics like Simon who are open-minded and let their early career researchers to spark new ideas and new research to the university. And then Professor Peter Nelson from Macquarie University, he works with Jane as well, with atmospheric pollution modeling. And perhaps, Peter, you are the pioneer in mercury research in the country, I believe, right? You and Bill together. So, and Bill, Peter is an important name between Australia and United Nations as well. So yeah, Bill also has been working with Mercury for a long time, doing analytical work. He's from the University of Canberra. And then Professor Cameron Holley from the University of New South Wales, here as well, present today. He works with regulation and governance. Dr. Carla Eisenberg from Charles Darwin University. So she has been checking mercury contamination in turtles that live nearby uranium mining, former uranium mine. So Professor Susan Lawrence, who is an archaeologist, she does really, really interesting research, multidisciplinary research. So she basically studies the history of gold mining in the country from the time of European colonization and how that impacts the environment. And then Professor Dr. Sarah Beavis, also from the ANU, also present here. She works with environmental sciences, especially with mercury in water. She has been doing brilliant work in Captain's Flat, and I have been having good opportunity to interact with students and teach some classes as well with her. Dr. Anna Lintern from Monash, she's an engineer, and she looks at mercury before European arrival and after and compare these concentrations. Dr. John Murrow from University of Melbourne, he works with microbiology. Dr. Janelle Stevenson from the ANU, also present here, so she works with me and Simon as well, and we all work with paleomercury, trying to understand past climate change in connection with mercury. So Professor Mark Taylor and Dr. Tony Morrison are from the Macquarie University. They work with Professor Peter Nelson, also doing atmospheric work. Dr. Robin Schofield as well from University of Melbourne, doing atmospheric science together with Steve Wuttenbe from University of Melbourne as well. And then we have here at the ANU 2 engineers, Mr. Jeremy Smith and Professor Takuya Suzuki. So they both work with remediation to control mercury in the environment. So they develop nanoparticles and polymers type of products to try to clean up the system. And then we have Dr. Alex Villa from the University of Queensland, who works with marine contamination of mercury. And so as you can see, our group is very diverse, a mix of early careers and senior researchers. And I have been taking a lot of advantage out of that, especially because I have been doing a lot of interaction with Darren, who has been a mentor for me as well. So this has been a very good opportunity for me and for the other researchers as well. So now we have Professor Simon Haberle from our School of Culture, History, Language, and we'll talk a little bit about the importance of collaboration for this type of project.
Okay, thanks very much, and thank you for inviting me to come and say a few words, and great to see so many people turn up from a whole range of places. What I really want to talk about is I guess a little bit about ANU and its role in the network, and I guess harking back to what Larissa said, a bit about the school in which we're in and how, I guess, such a school, it's a very diverse school, as you can tell by the title, but it's how such a place can actually nurture this multidisciplinary and interdisciplinary research. And as you might have gathered, much of the funding to support this came from the College of Asia and the Pacific and our school within that college. And the platform we have really is one that focuses on our Australia and people within Australia and our engagement in the world, and particularly in the Asia-Pacific region, which of course includes Australia. And these kind of sentences here that are fairly overarching and broad, but gives you a sense that our aim or our goals really are to use a whole range of perhaps disciplines and expertise to actually understand our place in the world and how we can actually influence and incorporate the ideas of a whole range of different cultures, and particularly Indigenous cultures around our region, and our school is very much focused on that. And so to be part of this network is actually really a great privilege, because we do, even within our school, we harness the expertise from sciences through to social sciences and humanities to try and understand our place in the world. So we really are building in this school this capacity to do interdisciplinary research, and that's certainly something that is put around quite a lot. You know, we're doing interdisciplinary research, but actually practically doing it is a real challenge. It means people have to, engage across unknown sort of boundaries, really, or borders between the disciplines, and try and break those down and actually work together on a big problem or an issue that they're engaged with. And I think we've been able to really achieve this and help to achieve this through the school itself. And we've got lots of people and expertise within the school and the college to actually, I think, be very positive and be able to support the network in many ways. So really, yeah, as I've said, this is really the intersection, I think, between STEM and HAS, which is the sciences through to humanities and social sciences. And this is a really exciting area, and an area that I'm particularly happy and very supportive of bringing investment to, and trying to make these such things as the Mercury Australia network succeed. So I think they have a role in really fostering much greater collaboration between different universities and government, non-government sector as well. I think that's the real value, and I think it's sort of exemplified in the people in the room here today, how we might actually use this issue around Mercury to actually bring people together and not only create wonderful science, which can happen in our labs, but also translate that through to policy and beyond, impacts beyond that. And I want to talk a little bit about that as well. But just back to our particular area, we work, Larissa and I and Janelle and others in our school, looking at this sort of deep time issue. And this is a fairly new area of study for Mercury. Most Mercury studies are contemporary, looking at what's going on in the modern environment, but there's a real treasure trove, if you like, of information that can be gathered from this deeper time perspective. And that's part of our expertise and the kind of frontier discovery work that we're working with and will bring to this network, I think. And we're working in a whole range of regions, and we work on these very deep records that maybe come from the marine sediments. We also look at our neighbours to the north, places like East Timor and other areas where, and New Guinea in particular, where artisanal mining activities are very prominent. In New Guinea in particular, that kind of activity is incorporating a lot of mercury into their work and having significant impacts on health throughout, and environmental impacts as well throughout that region. But within our lab, of course, we're working across a whole range of regions, from the north down to the south, in places like Tasmania as well. And these projects aren't solely necessarily focused on mercury, but actually incorporate a broader understanding of the environmental history, and this includes perspectives not just from scientists, local landowners, but also Indigenous landowners who are incredibly engaged with a greater understanding of this longer term history. And mercury actually can play a critical role in that. And we not only work from the tropics to our sort of Southeast Australia temperate region, but out in the deserts as well. And these are areas where the long distance transport of mercury and incorporation of other global climate change aspects can certainly be part of the work we do. But another great thing about being involved working at ANU, and I think many of the universities that bring their expertise to Mercury Australia, is the fact that we can bring these wonderful technologies to bear. And we were lucky enough to actually acquire, through ANU funding, a direct mercury analyzer, piece of equipment that's worth around $150,000, I think. But anyway, it's designed to analyse mercury in almost any bit of material, quantify mercury in that. So we actually use that in our labs, one of the few places in Australia that have that capability, and applying it to these fascinating questions. So kind of frontier technologies are incredibly important, but it's also what a network can bring, and what I'm really excited to see emerge and perhaps develop in this network is the capacity to actually do in-country and fieldwork. It's a very fieldwork-based kind of problem in many ways for students, and not just the members that are up there. It's for students and others to be involved with the kind of research work, and this is incredibly exciting, and it requires the kind of network approach to actually get a range of people involved. And of course, that then goes beyond that to how we actually translate and the outreach we can do with the information we have. And I think that's a real priority for a network such as this, to actually not just leave it on the blog or that kind of thing, but actually start to produce information that can be consumed by primary schools, through to the general public and other interested stakeholders, such as Indigenous landowners, non-government organisations, etc. And this is something that at the universities at least we do and engage with, but I think this gives us a real focus to actually produce some fascinating outcomes through the Australian network. And just to highlight, this is obviously an opening for the Mercury network, but in our school and our college, and the university, we're very engaged in the whole pollution idea and how that manifests itself and is influencing peoples around our region and the globe. And so we're, later this year, I think in September, we're having a interactive workshop, interdisciplinary workshop on the bigger picture of pollution, and people like Darren, who's here at the moment, an anthropologist working with pollution in places like India and so on. And this doesn't limit itself to mercury, but a whole range of issues come to bear when we start to look at this big problem that Australia is really at the heart of in this Asia-Pacific realm, where we have lots of plastics, etc., in the oceans and these big problems. So it's a model such as the Mercury Australia network model doesn't end there. This can be applied to a whole range of other problems. So this is something we also want to not limit ourselves to, but expand and think about into the future. Thank you.
So next I'd like to invite Peter Nelson, Professor at Macquarie University, come and speak.
So thank you, Larissa and Darren. Very pleased to be here. I like to tell people that at Macquarie we work on the brown end of the environment rather than the green end of the environment. So I've had a research career going back too many years that's looking at sources of air pollution and then also measurement of trace species in the atmosphere, and you'll hear a bit about both those aspects here. But in case you think, measuring air pollutants is a trip to the country, a nice trip to the country. This is a coal-fired power station at Callide in Queensland. The temperature that day was 45 degrees. These are dirty, noisy places to do any work, and this one's 50 years old. You have to climb up stacks to do the measurements, so it's not as easy as it might seem. So I got involved in Mercury about 10 years ago, just at the time when the United Nations was discussing the need for a convention in the chemicals area. So we already have, and we are a party, I believe, maybe the department can correct me, to the Stockholm Convention on Persistent Organic Pollutants, to the Basel Convention on Hazardous Waste, and the Rotterdam Convention on the transport of waste. So we were a party to all the chemical conventions. The UN started talking about a Mercury Convention in about 2003, so it's a long time. It took close to 15 years to get the convention agreed and ratified. And so we got involved initially through the department, and we did a study on the sources, the transportation and the fate of mercury in the environment. And we also reviewed the regulations that were in place at that time. So this was a job that we bid for and got with the environment, with the Department of Environment. Had a different name at that time, but probably 3 or 4 names ago. But the department was forward-thinking at the time. They wanted to think about the Australian response to the UN initiative in mercury control. What were the sources? How was mercury transported? Where did it end up? What were the existing guidelines, standards, regulations that we had in place for food, water, air? So we reviewed all that. And that was in the face of fairly poor understanding at the time, poor local emissions data, no local measurements, and no real capability to model the transport and fate at the continental scale. So we did 2 reports, and this one, the major one, is about 10 years old now. The conclusions in terms of where does mercury come from in terms of its emissions to the atmosphere, this is the summary table. So we have a number of unique aspects to this. So if we look at anthropogenic emissions, our industrial emissions are dominant. There are some emissions from commercial and domestic sources like dental work, other things, but the major sources are industrial. But those sources are significantly less than the sources of mercury that is either natural or re-emitted from legacy sources. And you can see that fires, huge ranges in uncertainty, but fires are significantly higher than our industrial emissions of mercury at that time. Now, if we were redoing this today, one of the good news stories is that of that 14 tonnes of mercury per year in 2006, which is when we calculated the inventory, there was a single source responsible for half of it, and that was Kalgoorlie gold mine. So a large-scale industrial source. And they've essentially controlled their emissions to at least 90% and probably more by changing technology. So they no longer smelt the ore to get rid of the sulphur, they now grind it in a particular way to eliminate that source of mercury. That means it ends up in the waste material. So it isn't going into the air, but it is still being released to the environment. So on the basis of that work, we've done a whole range of things, both locally with the support of the coal industry, who were very proactive about trying to understand this issue and what it meant for them, and then also internationally. So we did the first Australian power station measurements or continuous measurements of mercury species on a number of power stations in New South Wales and Western Australia. The inventory I've just talked about. We also measured mercury in the free atmosphere, so that we did the first gas phase concentration measurements of mercury, continuous measurements. There's almost no Southern Hemisphere data except for South Africa, although that is changing now, and that data provides constraints and tests of the global modelling capability. On the basis of that, we were invited to join the Global Mercury Observing System, which is led by the EU, and that continues to this day. So we have a long-term record, and I'll talk a bit about that for one of our stations, of background atmospheric mercury in Northern Australia. Measurements of mercury in wet and dry deposition, and measurements of mercury in fires, giving emission factors and firefighter exposure. And through all of that activity, and with the support of the department, I was nominated to be part of two expert groups through the United Nations Environment Programme. One, to develop a global inventory and to do an assessment, which happens every 5 years. So I've been part of that twice. And I was also the lead author for the expert group developing guidance material for the convention. So the convention was agreed, that is the legally binding document, but sitting behind that, there's a whole lot of guidance material for parties who want to implement the conditions of the convention. We've continued the long-term measurements in Sydney, in the Hunter Valley, Northern Australia, and in 2017 I became co-lead of the UN Environment Partnership on mercury from coal combustion with Leslie Sloss from the IEA Clean Coal Centre. And we're currently negotiating a large project with the Global Environment Facility to demonstrate mercury control in industrial processes in developing countries, and I'll come back to that at the end. So I just want to turn quickly to the long-term measurements that we have. In collaboration with the CSIRO, we've done measurements at Cape Grim at the baseline monitoring station. We have measurements near the notorious Liddell coal-fired power station in the Hunter Valley, which the government wants to keep running, but the owners can't see the financial argument there necessarily. But it's also near Bayswater Power Station, so we've been measuring there for close to 10 years. And then CSIRO and the Bureau of Meteorology some years ago started to develop Gun Point as a tropical baseline monitoring station to provide similar information to that at Cape Grim. It hasn't been as successful because of funding issues in terms of long-term measurements, but we've been measuring there since about 2014. We've also worked with the University of Toronto in new methods using passive samplers for doing atmospheric monitoring, which are much cheaper. So this is the Gunpoint site. It's a summary of a couple of years of data, and the background concentration we see at Gunpoint, most of the data falls within these boxes, but there are excursions from those boxes. But if you look at the majority of the data, it's around 1 nanogram per cubic metre. If you were measuring in the northern hemisphere, you'd be up somewhere between 1.5 and 2 nanograms per cubic metre. And that's a consequence of the transport of mercury from the north to the south and the lifetime of mercury in the atmosphere. So there's a north-south or a northern hemisphere, southern hemisphere difference. So that's why it's very important to have background data for the southern hemisphere. It's very difficult, though, to get funding to do this sort of long-term measurement. It's not very expensive to keep running once you've invested in the instrumentation, but it's not something the ARC is interested in. It doesn't sort of light them up in terms of innovation, but it's crucially important to do things like evaluate the effectiveness of the controls. The interesting thing about this site is that there's also appears to be, and we've now seen this a couple of years in a row, a seasonal change, which could be related to fires in that part of the world. It could be related to changes in ocean temperature, and we're working with the modellers at the University of Wollongong to try and understand that. And then on some occasions, we see much higher concentrations at this site. So we were interested in where they were coming from. This is the data taking out the averaging. So the green is the elemental mercury we measure at this site. You can see that seasonal variation. And what we've done here is looked at traces released in the northern hemisphere, tracked where they've been transported to. We've looked at rainfall, we've looked at wet season, dry season, relative humidity to try and understand the source of these variations. And it's pretty clear that on occasions at this site, we're seeing air that originated in the northern hemisphere and has been influenced probably by fires in Indonesia and other places. Okay, so I'm going to finish with what are we doing currently. As I said, we're continuing these long-term measurements of mercury at Australian background sites. But as you've probably seen from this talk, doing the work originally to understand the sources, transport and fate has meant that we've been included in the international activities, and we've helped to and will continue to help, I think, in the implementation of the convention. So the UN Partnership on Mercury and Coal Combustion has a yearly meeting, which I help coordinate. I was part of the 2018 Global Mercury Assessment that the UN has recently published, and have very recently been invited to be an informal observer on 2 working groups. So one of the crucial issues is around mercury concentrations in waste, because depending on how you define that, it could mean that mining waste is included in the convention in some cases. There also is a working group looking at effectiveness evaluation. So, that will involve measurements in food, in water, in the atmosphere, to try and look at changes due to the controls that the convention is introducing. But it's got a long lifetime. It might take 20 years for us to observe any particular change. And then finally, the thing that I talked about before, we're developing with the Global Environments Facility a $50 million US project to address mercury emissions from the industrial sectors covered by the convention. So that's coal-fired power stations and boilers, smelters, cement and waste. That work would be done in developing countries like Zambia, for example, that has lots of copper smelters, countries in South America, potentially. And I'll finish with this slide. It's probably not appropriate to take questions. I'm happy to answer questions at lunch, but just as a commentary on the network, I took this photo in Kruger National Park in South Africa. What you can't see in this is a whole other group of about 6 rhinos who were very happily drinking at the local pool. This guy, who's either an angry young man or a cranky old man, was off to the side, banished, very frustrated, angry. It was a good indication of working together is always much better. So I think that the network has a lot to recommend it, and I'm very happy to be a part of it. Thanks.
Thanks, Peter, and that enduring image of the rhino will last for a long time. I'd like to welcome James from the department to come and make a few remarks.
Thanks very much. It occurs to me that I think I'm the last speaker, that's right. So 2 things that results in A lot of the things I was going to say have already been said, and B, I'm conscious I'm the person standing between you and the food. So I'll try and keep my remarks brief. First of all, I'd also like to acknowledge the traditional owners of the land on which we're meeting today, the Ngunnawal people, and pay my respects to elders past and present, and any people of Aboriginal Torres Strait Islander descent who may be meeting with us today. I'd also like to thank the ANU College of the Asia and the Pacific and Dr. Schneider and Professor Sinclair for leading the development of Mercury Australia alongside Professor Haberle, Professor Nelson and others who are in the room or absent as well. So it's always great to be able to, part of my job, I'm an environmental regulator, so a lot of my job is saying no to people or telling them how bad things are and regulating them. I'm sure that the outcome of the work we're doing on Mercury eventually will result in some of that happening. So it's a nice thing to be able to come here today and celebrate the putting together of the partnership that is and will be Mercury Australia. I think it's a fantastic initiative, and certainly from our perspective, these sorts of initiatives are so important in terms of bringing knowledge together in an interdisciplinary way, as we've already heard about, to support the development and the progress of understanding, learning about, in this case, pollutants, in this case, mercury, but also learning about transmission pathways, how we can better engage and identify and, I guess, address some of those issues. I've actually been asked to talk to you briefly about where we're up to in relation to ratification of the Minamata Convention. So I'll run through that and then I'll turn to, I guess, just a couple of observations around that interdisciplinary nature of Mercury Australia towards the end. So as Professor Sinclair and I think sort of noted, in relation to Minamata Convention was put together over a 10-year period, basically in recognition of the impacts of mercury on human health and the environment. And so in 2013, after 10 years, the Minamata Convention on Mercury was formally adopted, and Australia actually signed that convention in 2013, which didn't then come into force for another 4 years while they waited to get enough signatories to the convention in order for it to enter into force. And that signature really was an indication by Australia that we were willing to abide by the measures established in the convention. Clearly, as has already, I think, been noted, the convention addresses every stage in the life cycle of mercury, from the time it enters the economy, through its uses and movements around and into the environment, to developing knowledge and capacity, and then to storage or safety at the end of what you might call its useful life. The focus of the Australian government, and certainly my area right now, is firmly on ratification of the convention, and we've been on a pathway for a number of years now towards that outcome. It's important to note that the government takes its convention obligations very seriously, and I guess sometimes Australia could be potentially accused of dragging the chain a little bit in terms of how we get to a point at which we're prepared to ratify. But I think what that does, sort of reflecting from my perspective, is that we are required to undertake a pretty comprehensive analysis of the pros and cons before we make a decision in relation to ratification, and that analysis includes public consultation, understanding stakeholder views across a range of different interests, and then analysing the costs and benefits and the impact of that ratification, both on industry, the Australian economy more broadly, health aspects, so the full range, if you like, and then determining what the national interest actually, well, making a recommendation to the government, I should say, in relation to what the national interest should be in regard to accepting obligations under the treaty. So in 2017, we consulted extensively on a number of implementation options, which many, if not all, of the people in the room will be aware was set out in a cost-benefit analysis and draft what we call a regulation impact statement. And as part of that, we went out and consulted very widely with industry and the community. Comments we received back on that were quite heartening, in that there's a very broad stakeholder consensus towards ratification being an appropriate step for the Australian government to take. And so across the past year or so, we've really taken that on board, but then also refined the regulatory impact statement based on a lot of the feedback we got from those sessions. We're now in the process of preparing a final regulatory impact statement and what's called a national interest analysis for the government's consideration. Now, clearly you'll all be aware there's a small event happening sometime in the next couple of months, which will mean that we're likely to put that type of our analyses in front of the next government, regardless of who they are, and we hope to be in a position to be basically then moving hopefully quickly to progress a new government's consideration of that national interest analysis and regulatory impact statement towards, and sort of taking the final steps towards ratification of the convention. The other important thing to note is that whilst the Australian government has the responsibility for entering into conventions on behalf of the nation, we don't own all the levers in relation to regulation, investment, and how those commitments that we enter into under the convention are brought to bear across the Australian community. And we find that, so a lot of the work that we've been doing over the past few years on both the, if I can call it that, the green and the brown side of our regulatory responsibilities, is around working with states and territories, around what their regulatory frameworks are and how they will be able to intervene or intercede on development pathways, uses, various potential destinations, I guess, or fates for Mercury, to ensure that when Australia, because the other part about our ratification clearly is we need to be able to impose the controls that ratification obliges us to impose. So that's, and a lot of that comes through legislative action, statutory controls. The Commonwealth can put in place some of those controls from an environmental perspective. Most of them belong to my division in the Environment Department in terms of their execution, but clearly states and territories often need to legislate to regulate or control in their own right, and that's a very important part of taking this forward over the next couple of years on the sort of expectation or proposition that Australia does ratify the convention. So I guess where we're at the moment is I think we're making good progress, and post an election, we're hopeful that we can progress quite quickly towards ratification, or recommending to a new government that they ratify a convention relatively quickly. Just in relation to connecting with research and collaboration, I guess I always start from the proposition that we, if you like, so my regulatory focus, our regulatory focus in the department stems from our statutory instruments and obligations, but we're certainly not the font of all knowledge, and more often than not, there's far more we don't know than we do in the department. So we strongly rely on a range of different information sources to support us in undertaking our obligations. The academic community is a key one of those things, particularly when it comes to developing new regulatory pathways and thinking about where we might take interventions in relation to, in this case, Mercury. And so I'd just like to say we've been really fortunate to have significant interaction with academic researchers on Mercury in the past, and from that perspective really welcome the initiative of the formation of Mercury Australia. I've got in my notes here just a reflection. The Secretary-General of the UN, Antonio Guterres, has called for the need for scientists to pursue their work for the greater good and for medical experts and citizens to be able to access that knowledge easily. And I guess where we see one of our key roles is participating, I guess, as government or governments more broadly, if I could be so bold to incorporate my state and territory colleagues, which they probably blanch at a little bit. But it really comes to we can helpfully be a means of getting research and knowledge out into the community, just as in the same way I think the academic community can help us in terms of pursuing knowledge and contributing that to, if you like, the regulatory effort in relation to, as I said, in this case, mercury. So we can really see that current research into mercury and other heavy metals will inform government policy and decision-making, but we can also see the flip side where government decision-making can help direct, inform future areas and support academic study and research. I guess ultimately that's a way of saying we're very keen for this type of collaboration to continue. And I guess my final reflection would be around that I think structures and frameworks like the one that's been put together with Mercury Australia are increasingly important as I think governments, stakeholders and the community more broadly, I think better understand the interdisciplinary nature of problems, that you can't just fix mercury from the perspective of science. You can't just, things are both, they're scientific, they're cultural, they're behavioural, and all of those elements need to be brought together in order for us to have effective regulatory outcomes and solutions. And so, and I note, I think it was Professor Haberle's recognition in terms of pollution. One of my other roles is I support the government in relation to waste more broadly, and the meeting of environment ministers in November last year introduced the National Waste Policy. We're currently working on an action plan. The more that we can draw on in all the areas of pollution, mercury being a key one of those, the more that we can draw on those interdisciplinary perspectives, the better that makes government policy and policy, program funding and regulation. And so this is a fantastic initiative. I congratulate you on it and really looking forward to working with Mercury Australia in the future, but also seeing other areas tackled in a similar way. Thanks very much.
Thanks, James, for that very thoughtful, supportive and encouraging presentation. So I'd like to invite everyone to go down and have some lunch, light lunch, and look forward to chatting and meeting. Larissa, did you have something to say?
Yes, so we hope that now with lunch is an opportunity for everyone to collaborate and create new ideas for the network. So the lunch is just outside here, so if you leave the room and take your left, you just keep walking and you're going to see on your left side. So yeah, thank you everyone for coming. We really appreciate it. And we hope to soon see things coming out of this meeting.